All right, we are going to do day two of factoring. These problems are going to get a little bit more involved, and these are problems where we actually have a number in front of the x squared. So we can't just do the puzzle method. Okay, so there is a process to this, and you have to make sure that you're following this step. But I like to keep it and teach you this way because it always works, and it's stuff that you already uh, using stuff that you already know from last class. Okay. It says check to see if this expression has a GCF. If so, factor it out. That's step one always. Is there a GCF? Factor it out. Step two here is we're going to multiply A times C. So we're going to multiply the first number times the last number. Now we can use the puzzle method. We're trying to find two numbers that multiply to A times C and add to B. Okay, we're going to write this expression as the product of two binomials, and then we're going to factor by grouping. So I will show you that in these examples. We're going to go through these steps so that hopefully you understand them. Okay. So the first thing that we're going to do is we're going to multiply A times C. So I'm going to write over here and I'm going to show you A times C. Okay. That is going to be 2 times 12, which is 24. So now I'm trying to find two numbers that multiply to 24 and add to my bx term, which is 11x. So I'm looking for two numbers that multiply to 24 and add to 11. Okay, so my whole goal is to replace this 11 with these two numbers. Well, what are the factors of 24? 1 and 24, 2 and 12, 3 and 8, 4 and 6. Well, there it is. It is 3x and 8x. So I'm going to take these two numbers and I'm going to replace this 11 with these two numbers. Again, where did I get them from? They're the two numbers that multiply to AC and add to BX. So I'm going to put 2x squared plus, I'm going to put a 3x plus 8x plus 12. So the key in the question you're asking yourself is, where did I get these two numbers from? Okay, all I'm doing is replacing 11x. Doesn't 3x plus 8x equal 11x? Yes. And then where did I get those from? It's from the factors of 24. Okay, so now I do what's called factor by grouping. I'm going to group the first two terms. I'm going to group the second two terms. I'm going to take out the GCF. The GCF is an x. That's going to leave me with a 2x plus 3. I'm going to take out the GCF, which is a 4. And that's going to leave me with a 2x plus 3. If you are doing this right, then these two in parentheses will always be the same. So we had a problem where the GCF yesterday or last class, these two things in the parentheses was the same. I factor out that 2x plus 3, and then I write down whatever's left on the outside as the other factor, x plus 4. Okay, so this right here, 2x plus 3 times x plus 4, is my factored form of this problem. Okay, so we're going to go through and do a couple of examples. Let's hope that you can catch on here. So we're going to multiply A times C. A times C is 4 times negative 3, which would be negative 12. Okay, so now I'm going to find the two factors that multiply to negative 12 and add to negative 4. Well, what are the sums here? So this is the sum, and this would be the product, right? So what are the numbers that multiply to negative 12? Negative 1 and 12, or 1 and negative 12. 2 and negative 6, or negative 2 and positive 6, 3 and negative 4, or negative 3, positive 4. And again, I'm looking for those numbers in this example that adds to negative 4x. That would be these two right here. So I'm going to rewrite the 4x squared. I'm going to put a plus 2x. I'm going to put a minus 6x. Notice that I put an x after each one of these two factors that multiply to negative 12 and add to my b term, and then a minus 3. And then I'm just going to factor by grouping. Okay, so I'm going to take out a 2x. That's going to leave me with 2x plus 1. Notice how when I take out a 2x, I'm dividing here. Okay, this is really important. If that number here is negative, I'm going to take a negative out. So I'm going to take a negative 3 out. I'm dividing all these by negative 3. That gives me negative 6x divided by negative 3 is a 2x. 3 divided by negative 3 is a plus 1. I know that I am doing this right because what I have in parentheses is the same. So I've got a 2x plus 1 and a 2x minus 3. I take what's inside the parentheses that's the same and I write it down once. Then I take what's on the outside and group it together. And again, if I went through and FOIL factor this out, 2x times 2x, 4x squared. My outside would be minus 6x. My inside is a plus 2x. That adds to negative 4. And 1 times negative 3 is a minus 3. Okay, so A times C is 49. I'm looking for two numbers that multiply to 49 and add to 50. Well, that would be 50. I'm sorry, 49 and 1, right? So I have 49x plus 1x. Okay, 49x plus 1x. So I'm going to replace 7x squared stays the same. This plus 50x is going to become a 49x plus x plus 7. This problem right here, when I factor by grouping, take a look at what happens. I'm going to take out a 7x. That's going to leave me with what? 7x squared divided by 7x is x. Divided by 7x, 49x divided by 7x is a plus 7. Here, if what I have in parentheses is already the same, I'm going to take out a 1. So the GCF here is 1. So I'm going to divide both these by 7 or by 1, and nothing changes. So if you notice, what's in parentheses is the same, x plus 7, and I'm left with a 7x plus 1 on the outside. Okay, so again, going through those steps from this second slide up here, I'm multiplying A times C first. Okay, then I'm finding the factors of A times C. This steps 3 and 4 is the puzzle method. So for this example right here, find two numbers that multiply to, or what's 4 times negative 15? It's negative 60. I'm looking for two numbers that multiply to negative 60 and add to my bx term, which is 4x. Okay, so one has to be positive, one has to be negative. I know that that is a 10x and a 6x, right? 10 times 6 is 60. One of these has to be negative, so I've got a negative 6x. So I'm going to take these two and replace my bx. I rewrite 4x squared. I put plus 10x minus 6x minus 15. And the nice thing is when you write these out, it doesn't matter the order you put them in. Like if you put a negative 6x here and a 10x here, it would still work. The signs matter. Okay, so I'm going to group the first two, group the last two. I'm going to take out a 2x. That's going to leave me with 2x plus 5. Here I'm going to take out a minus 3. That's going to leave me with, I'm dividing both of these by minus 3. That's going to leave me with a 2x plus 5. Again, I know I'm right because these are the same. So I have 2x plus 5, and I'm left with a 2x minus 3. This is the factored form. In all of these problems, I'm doing all of that work so that I can show this right here. Those are considered factored form. Okay. A couple more examples here. I'm going to multiply. I'm going to get a 12y squared. I'm ignoring that y squared, so I know that it's just 12y. Get out of there. Okay, so 4 times 3 is 12. I need two numbers that multiply to 12 and add to 7. So that would be a 4y and a 3y. That's what I'm replacing this with. So I've got 4y squared plus, I'm replacing this 7y with 4y plus 3y. And I'm going to put the plus 3. Okay, so again, when I factor by grouping, take a look at what happens. I take out a 4y, leaves me with y plus 1. I take out a 3, it leaves me with a y plus 1. So I'm left with y plus 1 times 4y plus 3. Okay. Here, multiply 5 times 6. That gives you 30. I'm looking for two numbers that multiply to positive 30 and add to negative 17. So they must both be negative. That would be a minus 15x and a minus 2x. So I'm going to take a 5x minus 15x minus 2x plus 6. Factor by grouping. Group the first two. Group the last two. I'm going to take a 5x out here. That's going to leave me with x minus 3. I'm going to take a minus 2 out of here. Again, when that first term's negative, you got to take a negative out. And that's going to leave me with an x minus 3 because I'm dividing these by negative 2. Okay, so I've got an x minus 3 and a 5x minus 2. This is the factored form. That would be my answer I would put into Delta Math. Okay, again, example, just taking out a GCF. We're looking for the numbers first. There'd be a 5. We take the smaller of the two variables, so x squared and a y. So I'm going to divide each of these by 5x squared y. That would be 3. Notice the x squareds disappear and the y cancels. Minus 25 divided by 5 is 5. X squared taken away from x cubed leaves me with an x. And 1y taken away from y squared leaves me with a y. That's just review from the other day. Okay, and then this one, this is a puzzle method. Notice I do not have to do the AC method here because there's no number in front of the x squared. I only have to do that when there's a number in front of the x squared. This one I can simply say, what two numbers multiply to 30, add to negative 13? Well, I know they have to both be negative, so I would say negative 1, negative 30, negative 2, negative 15, negative 3, negative 10, negative 5, negative 6, right? Those are all the combinations. Here's the combination that works. So x minus 3, x minus 10. Okay, and then now we go to the difference of two perfect squares. So notice that both of these are perfect squares. That's going to be an 8x plus 3, 8x minus 3. Again, reviewing, I take the square root of the first term. That's where the 8x comes from. I take the square root of the second term. One is always a plus, one is always a minus. This would be a 5 plus x, 5 minus x. So this is day 2. I am going to make another video and talk about a couple of these examples. For some of you that are planning to take pre-calc next year, I use what's called the guess and check. So I want to make sure that you have that. And for pre-calc, I kind of suggest the guess and check when there's a number in front. But this method always works. It's called the AC method. Good luck on your homework. Have a good day.